Thank you and welcome again. Not only is the universe stranger than we think, it is stranger than we can think. So argued Niels Bohr, one of the founders of quantum theory. We imagine our theories uncover how things are, but from quantum particles to dark matter, at fundamental levels, the closer we get to what we imagine to be the reality, the stranger and more incomprehensible it appears to become. Might science and philosophy one day stretch to meet the universe's strangeness? Or is the universe not so strange after all? Or should we give up the idea that we can uncover the essential character of the world, and with Bohr conclude that the strangeness of the universe and the quantum world transcend the limits of the human mind? Bjorn Ekeberg is a philosopher of science who researches the limits of scientific knowledge. He is the author of Metaphysical Experiments, Physics and the Invention of the Universe. Sabine Hossenfelder is a theoretical physicist who specializes in the foundations of physics. Hossenfelder has a popular YouTube channel called Science Without the Gobbledygook. Rupert Sheldrake is a biologist, author and researcher. Rupert is author of books like The Science Delusion and Ways to Go Beyond and Why They Work. So, that's the theme of the debate and our speakers today. And what we're going to do is, first of all, each of the speakers will respond to a question that we're going to put them, and then we're going to go on to a more fluid debate about some other issues. So the first question that I'm going to ask all of our speakers to address is, might science and philosophy one day stretch to meet the universe's strangeness? And to address this question, we're first going to ask Bjorn.
No.
Okay.
Or let me rephrase to use a little bit more time. I certainly hope not. What do we mean by strangeness? In this context, I understand strangeness to be that which defies our minds, or that which we cannot understand, or which we cannot control with our own rules of logic and reason. Now, certainly, if you look at this historically, there's no shortage of things that defy our minds or that defy our understanding. And this certainly also persists into an age of increasing science and technology. We have this general idea that science always progresses and that we know things better and better. However, this is not always the case. Science can also get stuck in certain patterns of thinking, and it doesn't always necessarily progress. This is a topic that I'll return to in another talk later, and I'm sure also in this panel. But if we look at history, and it's showing us two things about strangeness. One is that we will keep failing at understanding things. And the second thing is we will keep trying to understand things, because I don't think we have any choice. So I would like to think of strangeness for this debate as not the antagonist that we have to overcome. I think strangeness is the source of inspiration, the endless source of inspiration for our endeavors in science and philosophy. So that's why I say I hope that they never stretch, because what fun would be left if they do?
Thank you, Bjorn. And next, might science and philosophy one day stretch to meet the universe's strangeness? Over to Sabine.
Yeah, so I have to start quite similar to you in asking, what do we even mean by strangeness? So if we're talking about the kind of strangeness that we currently deal with, like quantum mechanics or dark matter, then I'm personally pretty confident we'll be able to solve it with the methods that we currently have. It's just a matter of trying a little bit harder. But there are other strangenesses where I'm not quite as confident, like when it comes to the question of what is consciousness. So personally on that matter, I think we'll eventually figure it out, but maybe I'm wrong. And then there are other questions where I'm like, I'm not even exactly sure what the question is. Like, why is the universe understandable at all? Is this a question that we can even formalize? Will we ever be able to address it? But I think the thing that we should focus on is much like he just said, is how do we make progress? So historically we have made progress by gradually building up our knowledge. We have learned a little bit more, then we made some new experiments and we learned a little bit more. And so I think we have to try to continue this progress to learn more. But it's quite possible that at some point we'll just fail and then we'll get stuck there. And in that case, there will be some strangeness left for us forever.
Thank you, Sabine. And now to Rupert. Might science and philosophy one day stretch to meet the universe's strangeness?
Well, I'd say science and philosophy already stretched a lot in relation to the universe. Until the 1920s, no one knew there were galaxies outside our own. Until the 1960s, most scientists didn't think that the universe had evolved in time from the Big Bang, which is now an orthodox theory. So there's been a huge expansion in our view of the universe. But all of this has happened within the framework of mechanistic materialism, the doctrine that matter is unconscious and that everything's caused mechanically in one way or another, governed by purposeless laws. I think that one of the biggest challenges for science as a whole at the moment is the existence of consciousness. And most mechanistic materialists think that consciousness is absent from the entire universe, all the stars and galaxies, all the other planets, everything else, except in a tiny, tiny fraction of matter, namely human brains, and possibly animal brains as well. However, and that leads to the so-called hard problem of consciousness, to explain consciousness in a universe that's otherwise unconscious. One way of tackling that is through the rise in the philosophy of panpsychism, which is surprisingly fashionable at the moment. And what panpsychists say is that, well, if there's a little bit of consciousness in electrons and atoms, then the fact it emerges in human brains is just a difference of degree, not of kind. Well, I think that argument's all right as far as it goes, but I'm rather interested in what happens if we take it further. Instead of stopping at human brains, carry on into the universe. And I myself have been thinking for quite a while about the question, is the sun conscious? Can the sun be conscious? Does consciousness have to be confined to brains? This cerebrocentric view of consciousness we're very used to, but traditional peoples have always taken it for granted that consciousness is much more extensive. Plato called the stars and the planets the visible gods because he thought they had intelligence. They were the bodies of which they had intelligence as well. And I published a paper last year in the Journal of Consciousness Studies called Is the Sun Conscious? In which I argue that the interface between the sun's activity and consciousness is its electromagnetic field. This may sound strange, but sitting right next to me in the form of John Joe McFadden is one of the principal exponents of the electromagnetic field of consciousness. His theory is largely confined to brains. He may be appalled at this extension of it, but I think you can make a perfectly coherent case that the sun has a conscious interface, a consciousness interfacing with its body through the electromagnetic field within and beyond the sun throughout the solar system. And if the sun's conscious, what about other stars? And if they're conscious, what about entire galaxies, which may have galactic minds vastly greater than those of stars, which are like cells in the body of the galaxy? And then what about the whole universe, the cosmos? So, leaving consciousness out, we get contemporary cosmology and physics. Putting consciousness in, we get a whole new way of thinking about the universe that may make it less strange because our own consciousness seems less anomalous in a universe pervaded by consciousness. Then many other questions arise. If the sun's conscious, what does it do with its consciousness? What decisions does it make? But my 3 minutes is almost up, so I'm not going to be able to tell you my speculations on that subject or anyone else's speculations, but they may come up later in our discussion.
But we do have a few minutes left, actually, because our first speakers were very succinct in their answers. So I'm going to stretch it a little bit further to press you on some questions. The question was about whether physics and science and philosophy can stretch. Now, we've spoken really mostly about science, but is one of the problems that science generally, since the days of Descartes, has generally drifted away from philosophy? Do we need more philosophy in science in order to try to make sense of the world? Are we missing something? Bjorn?
I mean, around the same time as physics became professionalized and when cosmology started coming into formation as well, philosophy went through its own break into two camps, so to speak. The philosophy also became professionalized. One part that was looking to be useful and subservient to science to clarify analytic terms, and another part that started wading into entirely different questions, some of them bridging on what Rupert is talking about. But it strikes me that in the last century we've had physics has tended to be alone in setting the terms and conditions for how to understand the universe, and that philosophy has either been useless or left to the sidelines. More or less, it would be my perspective.
What do you think, Sabine? Do you need philosophy?
Well,
Science?
I do think physicists should pay a little bit more attention to philosophy, because there are a lot of questions where philosophy becomes really important, where we get a little bit lost at the moment. For example, the questions about the origin of the universe is one of them, but also when it comes to the question of whether a scientific hypothesis has to be testable. Physicists, I think, don't quite get it right. They insist on this notion of testability, but then they often think that just because it's testable, it's also good science, which doesn't really work out in their favor. There are a lot of other examples where it would have been good if physicists have paid a little bit more attention to philosophy. Interestingly enough, since dark matter is one of the examples of strangeness that came up here, is that one of the best books I know about how to make sense of dark matter comes from a physicist turned philosopher, David Merritt, who tried to analyze the different research programs as to how much progress they've made according to certain philosophical approaches.
Okay, thank you, Sabine. And now we'd like to move forward onto the debate, and we're going to be looking at 3 questions. And the first question, theme 1, is: are there limits to what humans can understand? And first I'm going to give the floor to Rupert to address this question.
Well, obviously, our limited minds, which we evolved largely through the Stone Ages, it's rather surprising that we can think about galaxies and stars and physical forces and biological evolution and so on. That our minds are limited in the way they work. And as the philosopher Immanuel Kant pointed out long ago, the way in which we think, the categories of time, space, and causality were his principal focus, determine what we can think. Our minds work in a particular way, and we can only think in particular ways, and those might not map onto the rest of the universe. However, the traditional view, for example, in medieval theology, in, say, someone like Thomas Aquinas, is that our minds have a unique ability to map onto and understand the universe because they and the universe have a common source, namely God. And that human consciousness is like a scaled down, we'd now say, fractal version of divine consciousness. Divine consciousness contains forms, patterns, structures, understandings, meanings, and that our minds are adapted to that because they have a common source to nature. In fact, this is implicit in modern science. Even though many modern scientists are atheists, the founding fathers of modern science were all interested in theology: Newton, Descartes, Galileo, Kepler, and others. And they thought that the mind of God worked mathematically. mathematicians love the idea that God is a mathematician because, of all people, it makes them closest to God. And they thought that God was a mathematician. The mind of God determined the structure of the universe through mathematical laws, and human minds, through the gift of God-given gift of reason, as Descartes thought, can understand mathematics and understand the universe through mathematics. Both have their source in the divine mind. So Descartes, in a sense, was following a traditional view. But when people in the 19th century, when materialism became the dominant ethos of science, people simply said, well, there's no such thing as God or angels, and human minds are nothing but the product of physical activity in the brain. Then they destroyed this deep connection between the universe and human minds. Human minds then just became something that evolved through hunting woolly mammoths with stone implements and things. A much more limited view of human minds. But I think if we recover this much larger view of consciousness in the universe and a larger view of the nature of consciousness, then it's less mysterious than it might otherwise be.
Bjorn.
Yeah. May I ask you then a question, because you outlined here a sort of a panpsychist view introducing consciousness into the mix, and then a further extension or an extreme version, as you say, of that going even further with the sun. Would this eliminate the sense of strangeness if we understood consciousness to be everywhere? Because with consciousness, when we're talking about understanding, it's we usually are confined to reason or rationality, which is only a tiny part of consciousness to some extent. If we allow for consciousness to be everywhere along the lines that you outline, would there still be strangeness?
Well, there'd certainly be strangeness in the sense that there'd be vast amounts of the universe that are utterly unfamiliar to us, like distant galaxies and other planets. And there's plenty of strangeness here on Earth if we think about the different forms of life that exist in the deep ocean or in the bacterial or fungal worlds, or just the wide variety of animals and how they live, and plants. I mean, there's plenty of strangeness here on Earth if you think about it. So I think there'd be plenty of things that are unfamiliar to our minds. I mean, even if a star is conscious, it would be very difficult for us to understand what it's like to be a star.
Can I interrupt you there, Rupert? And since we're talking about stars, we'll ask Sabine, what do you think? Can a star be conscious?
Well, it depends on what you mean by conscious. So, I mean, so the question was, are there limits to what humans can understand? And I think the answer is obviously yes, because I don't understand what's the point of saying that stars are conscious. But more general, so our brains are only so big. There's only so much space inside, and it follows from this that there are some things that we just won't be able to understand. And I think we're actually reaching these limits right now, not so much in neurobiology. I think there's still a lot of stuff that we can learn with science, and also not in physics. As I just said, I'm pretty confident that the problems, the strangeness that we see there right now, that we can ultimately explain it. But we do have big problems understanding how to manage complex ecosystems. It's just something that doesn't fit in our head. Like, there are 80 billion of us on the planet. What effect do we have on the environment? We don't really understand it, and this is why we have so big problems with our environment. But to me, it always comes back to the point, like, how do we move forward? What do we do? What's the next step that we can do? How can we go beyond the limits of human cognition? And well, for one, it's a good idea if we try to not go extinct, but also we can try to extend our own mind by drawing on computers, for example, which we do with artificial intelligence. So I think there's a lot of potential in this.
Thank you, and that's a great point to move into our second theme, which is, should we take the mysteries of quantum mechanics and dark matter as evidence that the universe is incomprehensible? And back to Sabine to introduce this topic.
Yeah, so as I already said, I think the answer is no. But maybe I should step back a little bit and explain why I think people sometimes have a problem understanding me. So people often ask me, like, what is gravity? Or what does quantum mechanics mean? Or do you really understand quantum mechanics? And I don't really understand the question. Like, for me, if I have a mathematical framework and I can compute something that agrees with observations, that's what it means to me to understand something. And so I think what people ask for when they ask these questions, like, is there something, a metaphor or an analogy that you can tell me that I can map onto something that I already know? And there are limits to this. And I think the most obvious place where we reach those limits is quantum mechanics. There are just things happening in quantum mechanics, like the uncertainty principle or particles that are in two places at the same time, that don't have any analogy in our everyday life. And so in that sense, we will never be able to intuitively understand them. But we can still understand them in terms of mathematics.
Thank you, Sabine. And I'll pass over to Bjorn for, I want to ask a question following on from Sabine's. If Sabine's, if I understand you correctly, view of science is if you can make all the predictions work, you can use your equations to predict everything. If you could do that at a fundamental level and you knew all the equations, would that be it? Or is there more? Is there understanding that goes beyond predictions? Because ultimately a prediction is, electron moves this way or electron moves that way. Does that give you understanding? Is prediction the same as understanding? Or are we looking, is there a philosophy that kind of goes deeper and asks something beyond making predictions?
Well, I would say there's around limitations or limits that we are circling around. There's the obvious sense in which we are limited by what we know. We have limited reach. If we're talking about the universe, we are making projections on the grand cosmos based on the tiniest speck that we inhabit. So we have a lack of information. We have limits in this way. But there is a different sense in which limitation is crucial to scientific work, I think, and that's how we frame the problem in the first place. Because how we arrive at certain scientific, whether you would call them hypotheses or truths or whatnot, is not simply, as Rupert referred to, as the naked truth of reality as mathematics reveals it. It is a product of our history and how we come to understand the terms, how we name them, how we frame them, and so on. So that in itself poses limitations on how we can understand things. So for me, the answer would be that we fundamentally cannot reach past a certain, once we choose to frame a problem a certain way, there is something that then that framing becomes a blind spot, if you will, and produces its own set of problems.
But in quantum mechanics, if I understand it correctly, what we can't measure isn't really there. And I'm going to bring Rupert in to see how you respond to that.
Well, I'd rather concentrate on dark matter, actually, because here's a case where physicists found that galaxies don't behave like they ought to, according to the equations of gravitation. So one possibility was that it's governed by something other than just gravitation. Another is that they can make it fit their equations and give the satisfying answer by titrating in an unknown form of matter called dark matter, so the equations balance. What does it consist of? Well, you just invent it to fit the equations. And of course, there's no independent evidence for it yet. So this would be satisfying from the equation point of view, but unsatisfying if you say, well, to get an answer by inventing 5 times more matter than we know about and just putting it in to make the equation balance could possibly be just fudging it. Now, it so happens that there's an alternative theory. There are several alternative theories of galaxies. The one I like is with Greg Matloff, who is a professor of physics at City College, New York, and an astrophysicist. He has what he calls the volitional star hypothesis. And he thinks that stars can actually adjust their own position within galaxies by firing out jets. We know that the sun has flares and jets. They're jet propelled, and they can actually move around to take up the right place in the galaxy in the way that cells take up a right place in an embryo. And you don't require dark matter to explain embryology, and he thinks you don't require it to explain galactic structure, because the stars have a kind of autonomy and movement. Now, you'd never get there if you said we've got the equations, we've put in the dark matter that makes everything balance, and that's understanding. So I think Sabine actually challenges us to think how it actually works, rather than just to get the right answer.
Sabine, do you want to have a go at that?
Well, one thing that dark matter has going for it, and I should probably add, I'm not the biggest fan of dark matter, but one thing that it has going for it is that it's a simple explanation. And in that sense, it's good science. You need very few assumptions for dark matter. It's matter, as the name says. It doesn't interact with light. It has some average energy density, and from that you can calculate a lot of the things that we actually observe. That's it's a stereotypical example for a good hypothesis. Now, about the idea that stars can move around in a galaxy to put on some position, I don't know what observations that would really explain. Like, can you actually predict something with it? Have you tested
Yes.
it? Yeah, I was expecting you to say that. I actually don't really want to know. I mean, this is something that science is really good at sorting out, right? Which hypothesis has the biggest explanatory power? And I'm a little bit skeptical that this is going to convince astrophysicists to try something else.
Can I ask, Rupert, you claim, or at least proposing, that stars are consciousness? Well, we do have, as you know, we have a lot of people have thought about how you test whether, say, artificial intelligence agents are conscious. Has anyone seen the film AI? And there's something called a Turing test. You can kind of converse with a computer, and if a computer passes the Turing test, so Turing claimed that you can converse with the computer and not know that it's a computer, then you have to claim it, you have to accept that that computer is conscious. No computer, I think it's generally accepted that no computer has passed the Turing test. Now that's the test that you can actually apply. Could you do it to a star? Could you chat with a star and find out whether it'll pass the Turing test?
Well, obviously, I'm just having to speculate here, but let's take the idea that you can communicate with the sun. Now, obviously, Sabine is going to disagree, but millions of Hindus don't disagree. They say prayers, they do sun prostrations every morning. It's part of yoga. Their central mantra is the Gayatri mantra, a prayer to the sun to illuminate our meditation. Lots of people around the world think the sun is conscious. They offer prayers to it, and they try and communicate with it. Now, I'd suggest an experiment along these lines. Try and assemble large numbers of people who believe this is possible, and in India it wouldn't be difficult to collect lots of them. Discuss with them what kind of things might be done, and then, for example, ask them to say to the sun the usual prayers and mantras, and then, if you're conscious, please give us a sign, like 3 solar flares in a row, or something like that, some improbable activity of solar flares. And if the sun comes back with the requested signal, and if this can be done repeatedly, this would in principle be a way of testing for it. Now, this is a long way off, but I should also add that it's a long way off for any proof of dark matter or dark energy or these other things physicists believe in, or multiverses. So physics is full of improbable and untestable speculations. Actually, I think this is more testable.
Well, if anyone wants to fund an experiment in India where we take thousands of sun worshippers and check this out, I think we'll love to hear about it in the next How the Light Gets In meeting.
Could you tell them to not send the solar flares into our direction?
Keep them in India, please. Yes.
We've got a little bit more time on this debate. We've talked about dark matter, and I know it's you prefer to talk about astronomical things, but the other thing is quantum mechanics, and that does have some very strange aspects, like randomness. Now, randomness means that things happen at the quantum level, whether a particle disintegrates or not, And in principle, it's completely random. You cannot predict it. Now, we talked earlier that Sabine said that how you understand things is you can make predictions. These are fundamentally unpredictable. There's no way, it's generally accepted, you can predict how this happens. Now, do we understand something? If something like quantum mechanics, at a fundamental level, we can't predict why a particle disintegrates because it's a quantum mechanical entity.
Random variables are a well-defined mathematical structure. I don't have a big problem with that. Of course, there's the question, like, is this fundamentally really what happens? Like, what you said is entirely, what you said is entirely correct. This is what the currently widely accepted standard interpretation of quantum mechanics says, is that this randomness is actually fundamental. That's just the way that the world is. But it may not be actually the last word. You know, maybe there's a theory that underlies quantum mechanics where we can explain what's going on.
And that's certainly a respectable theory. Einstein, one of his most famous pronouncements was, God does not play dice. And that was because he didn't believe that this randomness was real. There must be some explanation for it. And I'm sure Rupert would probably have an explanation.
Well, no, I don't. I think that randomness is inherent in the structure of the whole universe. I think it's the only way that you can have conscious causation or other kinds of causation working. If there's indeterminacy at every level, as there is at the quantum level, at the sort of chemical level, at the level of neurophysiology, there's a huge amount of randomness. The level of the weather, as in chaos theory. At all levels of nature, there's a randomness that things could go one way or another way. If you have a higher level of causation, which can impose a pattern on that randomness, then you have a universe in which higher levels of causation through what I'd call, I think of it through what I call morphic fields, but there are many other ways in which you could have field theories or top-down causation or conscious causation where a pattern is imposed on otherwise random events. And unless there was a real randomness or freedom or indeterminism at every level of nature, we would have a universe which was either completely deterministic or and random, but with no possibility of top-down causation. So I think actually it's intrinsic in the nature of things, and an isolated electron may behave in a random way, but an electron in one of the molecules in your body is not behaving in a random way, it's behaving in a highly coordinated way as part of that molecule. So as soon as things come within structures, the randomness is replaced by an order which they take up. And if they break down, then it's released back to a more random state.
Okay, thank you, Rupert. Now we'll move on to our third and final theme question before we have a Q&A session, which is, what would the consequences for us be if we gave up on the idea that we could uncover the essential character of the world? So I know that as Sabine has, for example, said that we can and we will, and that's her conviction, but what if we can't? Are there consequences to that conclusion if that eventually becomes a conclusion in science? And I'll ask Bjorn to address that first.
Yeah, well, I think if it's if we ever gave it up, it would be because we would then have figured it out. I think the reason we are not giving up is because we can't figure it out, that it's a driving force. What we cannot understand drives us into doing more science and philosophy. But I think part of the problem with this question and how some of these questions are framed has to do with the word uncovering or revealing. This idea, which is intrinsic to modern science and the history of modern science, that emerged alongside with Christianity. We often have this view that it was that science and Christianity are opposed to each other, like the pioneering scientist Galileo versus the Pope and so on. But really, historically, they developed side by side and were highly complementary. This idea of revelation was central in both natural philosophy of science and in religion at the time. And this is basically the idea that God writes the book of nature, and the scientist's work is to try to decipher it. And that there is this code. There's a pervasive strand in Western modern thought that still exists in parts of theoretical physics as well, that you believe you can uncover mathematical laws or the actual imprint of the universe as it is. So I would suggest it gets us into trouble because it suggests that we somehow can reveal things and that there is a way to get to a total view. I think what we are seeing, and especially in the last century, is rather that science is a highly creative force. Science invents things, science constructs things, and I don't mean that in the sense of it's being just a social construction, but that it's literally creating a reality and creating a vocabulary for reality as we go along. So I would revert back to the original, like the first position, that I think science will be more like we would all have a sounder view of doing better science if we can take science off the pedestal of the total view and instead think of it how we constructively solve problems.
Okay, thank you. And Sabine, do you want to address this question?
So, so what would be the consequences if we gave up on trying to resolve this strangeness? Well, I'm afraid that ultimately progress would just entirely stall, because what's driven progress for the past 2,000 years or something is that we have understood increasingly more about the universe. And if we just let it sit, then for some while we'll reap the benefits of what we know already, but eventually we'll run out of new things. And this will not only affect science and technological progress, but also generally all creative processes. I always find it amazing. So I have a soft spot for reading fantasy novels, and it's quite amazing how often it's really obvious that the authors get their inspiration from reading popular science articles about physics. Like, I'm currently reading one about magicians, don't judge me, where they have a force field. And how does the force field work? Well, it slightly changes some of the constants of nature, like the speed of light and the mass of the Higgs boson. So you see immediately, where do they draw their ideas from? Well, it comes from science. And I think Stuart Brand said it very well when he said science is the only news, which is maybe overstating the point a little bit, but I think in principle it's right. We get these really new big ideas from science.
Can I also ask you to address kind of the reverse question here? What if science did do as Sabine projects it will, and explained everything you could predict? Is there room for God? Is there room for philosophy? If you can do it all with equations, where then? And I'll ask, because you guys have spoken, I'll ask Rupert to address that first. So let's imagine that Sabine is right, and we can predict everything down to the absolute limits of quantum mechanics. Is there room for anything else? Philosophy, metaphysics?
Well, I mean, that leads us straight into the philosophy of mathematics, doesn't it? And traditionally, in Western philosophy of mathematics, and came out of the Pythagorean and Platonic traditions, that mathematics is in the mind of God. It's in an ideal world that transcends the physical universe. And that's why the laws of nature are present everywhere, at all times, immutable, omnipotent. They have all the qualities of God because they're part of the divine mind. That was how the founders of modern science saw it as well. And so what's happened in modern physics is people have rubbed out God, but they're left with these free-floating laws of nature. And many mathematicians, whether they'd admit it or not, are secret Platonists. Roger Penrose is an actual explicit Platonist. So, in other words, they believe there's a mathematical realm that's totally transcendent, on which this world depends and which it reflects. Now, that's a form of theology. And I personally think it's a very limited form of theology, because I think the mind of God contains a lot more than mathematics. And so I think if we have the idea of a divine mind containing potentially all forms and potentially all creativity, through the ongoing creative action in the Christian tradition of the Holy Spirit. Tomorrow is the festival of the Holy Spirit, Whitsun or Pentecost. We have a creative action working through nature which is divine in origin. And I think it's quite possible to integrate theology, both Christian, Hindu, and other forms of theology, with the scientific worldview in a way that enriches both. That's my own personal view, and perhaps not shared by many, but I think it makes most sense of these things. And if we don't have something like that, we're left with free-floating mathematical laws with no ontological basis at all as the basis of our description of the universe, which I think is incoherent.
What do you guys think? Do we need, if mathematics explains everything, do we need to explain mathematics? Does there have to be a metaphysical space out there that gives the power of mathematics?
I think it's impossible to do mathematics without having set out some sort of limitation or ground assumption before you get started. There's not, if you look at Einstein's book on relativity, he starts off by outlining, there's a few assumptions like principles of special relativity and principal equivalence and so on, and then you get into a whole lot of mathematics. Usually, I think physicists that are trained more on the mathematical side, they skip past the assumptions and say, okay, how can I make this work? And then you start calculating. To my mind, it's a delusion that you could ever understand things purely mathematically. I also believe, like Rupert, that's a theological idea at the core.
Sabine?
So I'm not entirely sure that I would agree it's theological, but it may come as a shock to some of you, but I partly agree with what you said. There are a lot of physicists who are Platonists, and they don't really understand that this is not a scientific position, and it's not a good thing if they conflate their beliefs with the science. But to come back to the question, like, do we have to explain mathematics? I actually think that we reach our limits before we even talk about where mathematics comes from. If we just look at what we can explain with physics. So you made it sound as if I think that we can actually, at some point, explain everything. I don't think so. I think that whenever we have some theory that explains our observations, we'll always be left with questions about the theory. Like, why this theory? Why not some other theory? And I think that some of those questions will ultimately be impossible to answer, because part of the answer will always just be because it explains what we observe.
Agreement from our panel. So on that note, I'd like to thank our panel.